Model of the closed loop system on excavator bucket position. Valery, I hear you.
I'm
Valery?
here. I'm here.
Okay. Are you ready?
I try to share my screen.
Okay.
Okay. We are greeting you already.
Thank you. Can you hear me?
Yes, sure.
And can you see my presentation?
Yes.
Thank you. My name is Valery Tityuk. I'm professor of Department of Electromechanics in at Kryvyi Rih National University. And I would like to present to your attention the report of the authors Valery Tityuk and Denis Mrachkovsky, modeling of the closed loop system of excavator bucket positioning. In the course of continuous development and complication of interconnected electrical, mechanical, electromechanical, and control systems, modern excavators machinery is transformed into a mechatronic complex. For mechatronic complexes of mining machines, due to their significant installed capacity, the energy efficiency of their functioning is of great importance. The main factor affecting the efficiency of mining machines is the level of operators' qualification. Therefore, the development of mining equipment control systems based on artificial intelligence systems will be the defining trend of their development in the near future. In the mining industry, the production of new generation equipment is characterized by a functional and constructive combination of electromechanical converters with energy and information components, i.e., the creation of mechatronic complexes. Excavators are made with different interchangeable tools as shown on this slide, and in any case the working body of excavator has rigid connection with the machine mechanisms, which limits the degrees of freedom. The mining enterprises of the post-Soviet space, characterized by high hardness of extracted iron ore raw materials, electric excavators by scheme, straight shovel or rope shovel are the most widespread. At the enterprises of Europe and North America, hydraulic excavator on the scheme backhoe are more widespread. That determines insignificant attention of foreign scientists to researchers of excavator on the scheme straight shovel. This slide shows the current structure of the excavators fleet at the open pits of the Kryvyi Rih iron ore basin. About 65% of the fleet are excavator of EKJ8 and EKJ10 types. The most widespread type of electric drive used in excavator up to now remains the Ward Leonard system, also known as generator motor system. It should be noted that there is a systematic process of replacing obsolete Leonard electric drives by the modern electric drive system three-star converter with DC motors. The most complex part of the complete excavator model is the model of mechanical part of the excavator, which determines the nature of the bucket movement under the action of individual mechanism. The kinematic schema of the straight shovel excavator was analyzed. The main goal of kinematic analysis of the straight shovel excavator is to establish the relationships between the coordinates of excavator's electric drives and the special location of the bucket in the process of the technological cycle execution. This slide shows the obtained expressions for solving the direct and the inverse problem of excavator kinematics. These equations are linking the coordinates of excavator individual mechanisms with the spatial position of the bucket according to kinematic schema of the excavator. This slide shows the proposed enlarged block diagram of the closed loop system of automatic control of the excavator bucket positioning, which includes the subsystem for formation of the required trajectory of the bucket movement, determination the positions of individual mechanisms of the excavator by solving the inverse problem of the excavator kinematics, closed loop systems for controlling the position of individual mechanisms, and the subsystem for calculating energy consumption during the technological cycle. This slide shows the realization of a complex model for complete electromechanical excavator system with closed loop control of the excavator bucket position developed in MATLAB with SimPower Systems library. This model includes, among other things, models of the electric drives of individual mechanisms of excavator and the model of main synchronous motor. The model of the electric drive of the excavator crowd mechanisms and simulation results are shown here. This slide shows the model of excavator's main synchronous motor and simulation results. The general modes of the processes and the correspondence of the numerical values of currents and speeds to the rated values confirm the adequacy of this model. Examples of calculation of different bucket trajectories and determination of the parameter such as length and energy consumption is shown here on this slide. A comparative analysis of the excavator's operation when performing different trajectories is shown in table. As can be seen from obtained results, the length of trajectory 2 is reduced by 27.4%. The execution time of trajectory 2 is reduced by 22.5% compared to trajectory 1. But at the same time, the power consumption of trajectory 2 is increased by 22.8%. From the obtained results, it can be hypothesized that the control strategy for maximum speed is in conflict with the control strategy for minimum power consumption. The choice of the optimal bucket trajectory requires the development of a specific combined criteria that takes into account not only the changes in energy consumption, but also the changes in the productivity of the excavator with a change in the length and duration of technological cycle, and is the subject of further research. For qualitative visualization of the obtained solutions, a full-size 3D model of the excavator was developed in 3D Studio Max program. The display of the excavator's 3D model was controlled with the help of Unity, a cross-platform environment for computer games development, which is used to create many applications for visualization of mathematical models. Here is what we got. Sorry. First of all, the video you see on this slide is not a cartoon. It's the result of coordinated work of two models. The first model is a model of the excavator electromechanical systems in MATLAB, which calculates the position of individual mechanisms taking into account the excavator's kinematics. The results of calculations is transferred to the Unity scene and controls the position of individual elements of the excavator 3D model. As a result, we get a photorealistic scene of excavator operation close enough to reality. The technological cycle of the excavator includes digging, moving the bucket to the truck and unloading, and moving the bucket to the starting point. You can see the workout of the technological cycle on different trajectories. The panel at the top left corner shows the process cycle time, the excavator's energy consumption, and other characteristics. This allows us to compare different trajectories of the excavator bucket and optimize its performance. The availability of a 3D photorealistic model of the excavator makes it possible to develop innovative control systems in which the information necessary for control is extracted by an artificial intelligence system with vision elements by analyzing images of the industrial environment. High accuracy of the mathematical model of excavator electric drives in combination with photorealistic realization of 3D model of excavator motion allows solving many practical and scientific problems. For practice, the most important task is to improve the training of excavator operators using 3D visualization in modern technical means. Further development of autonomous virtual reality devices will bring a revolution in this area of trainings. In fact, the history of the development of technical tools for operators training has a long and interesting history. I would like to mention the following. In 2007, the company Modex, together with Department Sawe of Kremenchuk University and Professor Alexei Chorny, was engaged in the development of an equipment for training of excavator drivers. On this photo, you can see some results of those developments. The developed virtual model of the excavator allows us to proceed to the solution of the following theoretical problems. Let us represent the excavator operator as an element of the excavator control system. Then we can synthesize an adaptive excavator control system that compensates for the operator's inertia and non-linearity. It's necessary to develop criteria for the quality of the trajectory of the technological operation execution using the theory of efficiency of technical systems. It's possible to develop an excavator control system using artificial intelligence equipped with vision systems. Thank you for your attention.
Yes, thank you. Okay, do you have any questions?
Paper open for discussion. So may I ask you, there's some question which concerning the using the synchronous motor. Let me understand why it's synchronous motor, what kind of synchronous motor using in excavator as a main drive?
It's traditionally uses standard synchronous motor with salient poles nearby 650 kilowatts power.
Okay, thank you. So it's traditional electric motor, yeah, which are using in this equipment.
Yes, I use traditional electric motor and traditional model of park based on park equations for this model.
Yes. So as far as I can understand, in this paper you investigate only one of the three previously shown scheme of working of excavator, as I could understand, because in the starting of your work you show for us, yes, this one. So in this your work you study only one of these schemes, so you have in progress to use another one. Is it so?
Thank you for your question. Our goal was to develop the model as a rope shovel excavator because of there are many investigations and many papers about backhoe in foreign scientists, but there are not enough papers and research for this type of excavator because this type of excavator widely used in our country and on post-Soviet Union space.
Okay, thank you.
Thank
you so much. So yeah, so as I can understand, the final goal of the paper is how to increase the level of training of the operator of excavator as a main goal. Yes or no? I understand like this. Yeah,
when we use the developed model, we can increase the level of excavators operator training. I saw this model when it worked in Oculus Quest 2 virtual reality glasses. It's absolutely new emotions, absolutely new level of interactivity. but the main goal of our report is not a training of excavator operators. The main goal is to increase efficiency of using mining equipment with a cycling or operation type.
Thank you. It's understandable. Yeah, thank you so much.
Okay, thank you. Thank you, Valery.
Thank you.
I gladly invite this closing speech main organizing person of local level is organizing committee chair, head of Institute of Education and Science and Electrical Engineering and Information Technologies, our university, Professor Alexey Chorny. This organizational issues.
Recording in progress. Recording stopped.